Welcome to Walkabout the Galaxy, the holiday astronomy podcast, where the science is universal, the opinions are personal, and the topics are diverse. We are Strange Charm and Top the Astroquarks, also known as Josh Cole, Addie Dove, and Jim Cooney, coming to you from the Walkabout studios at the University of Central Florida. Be sure to stick around at the end of the episode for two is what I've written. Actually, I want to start this whole thing over.
Okay.
Because one thing I was going to say is, just listening to other podcasts, I'll say we're Strange Charm Top the Astroquarks, also known as Josh Caldwell.
Addie Dove.
And Jim Cooney.
Oh, I like it.
Coming to you from the Walkabout Studios at the University of Central Florida. So
Okay.
we do that?
Yeah.
Okay. So they hear, so we get the voices early. Ready? Take two.
Cut. Start. Action.
Welcome to Walkabout the Galaxy, the holiday astronomy podcast, where the science is universal, the opinions are personal, and the topics are diverse. We are Strange Charm and Top the Astroquarks, also known as Josh Caldwell.
Addie Dove.
And Jim Cooney.
Coming to you from the Walkabout Studios at the University of Central Florida. Be sure to stick around at the end of the episode, hear us sing a song.
Really?
That's actually not going to happen.
Okay.
Wow.
Our stumpers are science fictional. Okay?
Seems appropriate.
Yeah.
Jim,
Yeah.
Star Trek Enterprise or Star Trek Discovery? The
Well,
two Star
Are you
Treks that
referring
are
to
named
shows
after...
or ships?
Oh, well, take your choice.
Oh.
Interesting. I'll choose between the shows, even though I'm entirely ignorant because I haven't really seen much of either one.
It makes you wonder why I ask you these questions.
It does.
That's why they're stumpers.
I feel bad because I consider myself a Star Trek nerd, and I
You're not.
continuously tell people how much better Star Trek is than Star Wars, et cetera, even though I like both.
Uh-huh.
And yet I haven't seen these Star Treks. But I'm going to, uninformed opinions are our specialty, or at least mine. So Star Trek Enterprise is my
Oh,
choice.
interesting.
Because it's got Scott Bakula,
Yes.
and he was on
Yes.
Quantum Leap,
True.
and that
Correct.
was awesome.
You're correct.
Okay,
Yeah.
that's as good a reason as any, I
Sure.
suppose.
Yeah.
Also,
Enterprise got pretty dinged when it was on, but I think now in light of Discovery, people are like, it wasn't that bad.
so you get a pass for Discovery because it requires a separate subscription
Right, it
service.
does. I mean, how many subscriptions?
There's a proliferation of channels.
It's super
there's-
frustrating.
There are more streaming channels now than there were just regular channels when I was a kid.
Yeah, right.
And that's
It used
not,
to be 3
not counting
or
all
4,
of the
yeah.
other hundreds of other sorts of channels.
Yeah.
Addie,
Yes.
Baby Yoda, or Rosemary's
You didn't
Baby.
have to say anything else. The answer was going to be Baby Yoda. Or as some people say, I guess, the
What?
child,
The
right?
child.
So you've seen The Mandalorian?
I have.
I have not.
Is it finished yet, or is it where
No,
are we in
because
the episodes?
they're doing weekly episodes or whatever.
Right.
And
But
it's
it's-
not finished. It's
many-
maybe almost done. Maybe
is
one
it
or two more
is
episodes.
it a 10 or a 12
I don't.
episode
They're usually
season?
like 8 these days.
I think it's.
So.
I think 7 have come out at least at the time of this
Okay.
recording, which we should mention is our final Walkabout recording of 2019.
19.
So
Wow.
Right
happy
on.
2019!
Happy-
It has been, as we had advertised it would be, the year of the Astroquark.
Indeed.
Actually, though, 2020 will be the year of the Astroquark.
Part 2.
The second year of the
The
Astroquark.
second year of the
The
Astroquark.
second annual year of the
Yes!
Astroquark.
Yes.
There we go. Perfect.
Yes. Yeah.
So the child or Baby Yoda.
Baby
It's
Yoda.
irresistible.
It's like every third entry
Meme
I
you
see
see?
in my Facebook thing
It's
is
about
a Baby
Baby
Yoda
Yoda.
thing.
Yeah.
So of
As
course,
it should be.
and it's a Baby Yoda in the same way that any baby is like a baby Jim.
Yes.
'Cause
Right,
it's-
right. It's not
It's a-
actual Yoda.
It's
just
whatever species Yoda is.
Right.
It's a child of his species, but the child is actually like 50 years old.
Right.
But it looks like a child, but it still looks like Yoda. It's still like sort of oldish,
Oldish kind of
small,
looking,
ugly
but
looking.
I believe I
But
went on a rant
you
about
did
this
rant
last
about
time.
this
I
already.
won't again.
Yeah.
Yeah.
But with the eyes, the like giant eyes that make humans want to protect a small
Yeah,
thing.
is that what it is that makes
Yeah.
universally makes babies
Adorable.
Yeah. So
And
they
yeah.
didn't have toys ready available for this.
Which blows my mind.
So-
How did they not know
Yeah,
how
it's
big
like
a
Star
marketing
Wars
thing that would have been?
He's like marketing
Disney.
genius
Yeah.
generally.
Well, apparently they didn't want a spoiler out, but it seems they could have maybe timed things. But I guess
Yeah.
the production time scale to get a toy developed, it would have come out that there was a Baby Yoda toy coming.
That makes
But it's not like it was that big of a spoiler because it's in
No.
the first episode.
And also, like, if you just saw that they were developing a Yoda toy, and maybe you could have just thought, like, oh, that's weird, they're developing a Yoda toy. Maybe it's with, like, the new Star Wars movie or something.
Yeah.
But, yeah.
Yeah.
I don't know.
So,
Anyway.
but
there will be at some point Baby Yoda toys.
there are a lot of 3D printed models for Baby Yodas
I also
out there.
saw this really awesome knitted one that someone did online.
Uh-huh.
It was amazing.
Yeah. Today we're talking about
Yoda.
Only Yoda. The all Yoda episode.
It's the
Happy
baby.
holidays.
We have to, but then if we did an only Yoda episode, we'd also have to speak like Yoda, and that would be really
that would be
challenging.
We would
challenging.
Have
It would be.
practice would be needed, or practice needed would be something.
Yes, point.
Yes, you've made your point. Your point.
Your point you have made.
There you go. Addie's better at Yoda talk. Today we've got a bunch of space news. Science-wise, I-2 Borisov has made its closest approach to the sun, but not quite yet its closest approach to the Earth. We've got hot spots on a planetary target and on an astrophysical target, Enceladus and a pulsar to talk about. Methane on Mars is the new water on Mars.
Just by methane?
You know what that means. But first, this episode of Walkabout the Galaxy is brought to you by Blue Origin. For a truly celestial break from the hustle and bustle of terrestrial life, Blue Origin has a smooth, warm flavor that will transport you to the exosphere and beyond. With a dash of our special blend of minerals from our proprietary Blue Ore, you'll wonder if we got our supplies from our own planet or an extraterrestrial mining operation. Blue Ore lends our gin a unique flavor you won't find anywhere else on your Walkabout the Galaxy. So the next time you need a break from the ordinary, don't just try extraordinary, go extraterrestrial with Blue Origin. Blue Origin, liquid starshine.
Ooh.
Interesting.
Starshine.
I made that one up.
Oh! I was going to be really impressed that there
It
was
was
somebody
like-
that did that.
Yeah.
Or like Goldschlager, maybe.
I
Could
was-
be liquid starshine.
I made a cursory search for fun taglines
Yeah.
from alcoholic beverages, but
There
they
are a
were
lot.
all just sort of like, Jameson is great, or whatever. So it's like, Blue Origin, Jameson is great.
The funny thing about that is all of the alcohols just have Jameson as great.
Oh, right.
Is Blue Ore gin related to blue milk from Star Wars? Is it the same
well, that's an interesting.
constituent that makes it blue? Is it the same mineral?
It may be.
Possible.
It may be.
Or Romulan ale. Wasn't that blue?
Was it?
Possibly.
I think
Can you have one?
there
on your
was.
shelf? There was a blue.
There was a
version.
blue drink in that one by any other name, the Star Trek episode by any other name, where Scotty gets this alien drunk and he drinks this whole. They drink their whole bottle. I can't remember if it was Romulan ale or not though, but I actually have a.
I've seen a bottle of something.
I have a beer that's Romulan ale up there. Diego can check. It's behind.
Is it
generally what ale
it's,
means.
It's up on the top. Is it? I don't even know.
But I think that Romulan ale is not blue. I think. Oh, it is.
There it is.
That's blue.
Let's bring it.
I
I knew
for
it.
can have it.
Blue.
for
They had
our,
it in like Star Trek 6:
Blue
The Undiscovered
Origin
Country as well.
is maybe the same color as this.
Romulan ale.
Yeah,
This can be here on the table now.
yeah.
Perfect.
Space news.
Space news. Did you wake up this morning?
I accidentally
To see
woke
a
up
launch?
3 minutes before the Starliner's first flight into space.
You felt the
And
trembles.
I didn't feel subconsciously somehow.
yeah.
And a beautiful looking launch from
Yeah.
the beginning, from our vantage point here in Central Florida. Really
Atlas
nice.
5 rocket performed
sort of
nominally.
Right at dawn.
Mm-hmm.
Then things went a
Totally
little
missed
bit off
Nominal. Yeah, the launch was great. The Atlas V was the rocket. It performed nominally. It got into its initial orbit that it was supposed to get it into, and then the Boeing Starliner was supposed to take over and do a couple of things and then do another burn to get it into the proper orbit that then it would be in the orbit to intersect with the ISS. But there was something weird with the clocks on Starliner, and then they didn't. There was a delay in when they synced up with the TDRS satellites that help the relay satellites that help them communicate properly. And so there was a weird delay in that, and so they didn't sync their time correctly, and they thought that they were already past the burn that they were supposed to do.
Oh.
And so they didn't do the burn they were supposed to do. And then it was doing all of this stuff to like put it in the correct orientation because it was confused about
Where
and
when
when
it was.
So then they didn't have enough fuel to actually put it into the right orbit. So it's going to orbit now for a few days, and it was going to land in White Sands anyway, in
New Mexico.
And so it's going to land on Sunday instead of like later next week. So it's going to orbit
Okay.
for a few days and do some orbital maneuvers and demonstrations and stuff like that, but it will not.
So are there any
Along with the
important? I mean, it had
ISS.
supplies for the SSS, right? Or
No, I
ISS.
don't think it had much.
It had a couple 100 kilograms of stuff, not a
Oh, okay.
full.
So not deeply important. They're not going to go hungry up there or anything.
No.
No, it wasn't the sort of fully stocked cargo
Supply cargo.
delivery. And this is, we should just remind, it's a capsule that eventually will be carrying people up, but no people on this test flight.
Yeah, and a lot of what they were saying, right, is that if there were people on board, this would have been a super easy error to fix, and so it would have been a fine flight.
Yeah.
Because the people would have been like, oh, this is wrong, set the clocks correctly, blah, blah,
Right,
blah. So
right,
they would have
yeah.
been able to do the burn on time, and it would have been fine.
We're not yet redundant. We
That's the
humans.
thing, right? So that's one of the big arguments about, like, for experiments we build even, right, is automation can be great to some extent, but, like, sometimes just having a human there to do a thing when it's supposed to happen.
Right.
is
Why
pretty
did it? Why
clutch
would that
still.
require a human on board that thing? Couldn't the people on the ground realize it's not firing right and then fix it?
But you have to have a relay satellite to
You'd-
communicate with that spacecraft if you're on the ground, and there's a delay, and there's all these different things, and that was part of the problem.
Yeah.
Like a delay.
Well, so
It
you
can't
would
be more than a second.
you would have to know, you would have to like plan to set that up to have all that in place.
Okay.
I mean, so yeah, so they
We're-
did
we're
eventually
in-
take
we're
control.
Jim is talking about Star Trek Discovery mode here. Where we don't
no, I
really
mean, so
know.
they eventually took control of the vehicle, but it was on the order of 10 minutes or something before they figured out what had gone wrong and what all was happening, and then decided like what they were going to do. I
Right.
think.
But it's weird to me that people on there would have been able to figure that out faster than people on the ground.
But in real life, that's how it works.
You could design, I imagine, that you could design things in such a way that people on the ground would be able to respond almost as quickly with whatever small light travel time or whatever communication lag there is
Right,
of a few
right.
seconds.
Yeah.
But it's not, it's planned to have astronauts on board, and then the test flight is planned to work
Right.
autonomously.
Okay.
So it's not planned to have somebody on the ground flying it by stick.
Right. Okay.
Right.
Fair enough.
Probably. Yeah.
But it is planned to be able to have, if there are people on board, to have them be able to step in and,
Right.
and do things.
Right. So the people on there are redundant, but aren't, but only because we designed it. For them
Yeah,
not
I
to
mean,
be.
probably nominally the flight would have been automated even if there were humans on there, right? They would only do things if necessary.
Yeah.
You remember this classic Star Trek episode where they tried to replace Kirk with a computer?
Vaguely?
Do you remember the name of that computer? Because there's something in our lab that is named after it.
Is it
Not our choice.
not our choice, but it's named that in our lab?
Yeah.
I don't know.
You don't remember? You hated this thing as much as Kirk hated the one in
Oh, no.
the original
There's
Star
a
Trek
lot of
series
things I
episode
hate.
called The Ultimate Computer.
Uh-huh.
And that, do you remember? You're not, boy, you're just over 3 on Star Trek stuff.
It's
Jim.
not core?
No, it's
I
the
remember that.
M5.
Oh! The
and
M5.
the M5 and the M5 malfunctioned.
Of course it did. Just like in the
Probably
lab.
exactly like the Starliner thing malfunctioned or whatever. And
Yeah.
but so there was a lot of discussion
I
about whether or
hate the
not
M5.
Kirk was redundant. You see, as a decider on the Enterprise, and
Yeah.
as it turns out, he was not.
Yeah. By the 24th century, I bet humans will be.
So
Right.
Starliner, so I don't actually know like what the next steps are because they were going to do an in-flight abort test then after this, and then they were going to do a crewed flight not that long after, but I don't know if they have to now do another demonstration docking flight or not.
I would imagine they would want to do a docking flight before they put people on it, but I don't know.
I would think so too.
We don't know.
Because I don't think Starliner has docked with the ISS at all yet.
No, this was its first time into
Yeah.
space
Yeah.
at all.
Yeah.
And it is in space.
Yeah.
Ta-da.
Yay.
Let's see, the mole is digging again.
Can we, okay.
What do you want to say?
So the competition is SpaceX.
Yes.
And
Oh, yes.
they
Update us.
are supposed to do their in-flight abort test on January 11th now or something like that. So, and they haven't done that yet. They did a pad abort test,
Right.
and then they have done their first flight that's gone to station
Right.
and landed and come back, and then
It's
that's the
all
one.
in different orders.
That's the one that blew up
Okay.
when they were testing prior to the in-flight test on the pad. That one blew up. Anyway, they're supposed to do an in-flight abort test on January 11, and then nominally their first crewed flight in February.
Oh, exciting.
Yes.
So both SpaceX and Boeing / ULA, I guess, have contracts to take astronauts to the space station. So it's sort of a competition. At the same time, in principle, they will both be operating
Yeah.
and doing these things. So
That
they
was
have
one-
kind of both won.
I was wondering earlier today if
It's-
Elon Musk was happy or sad about the results of this morning's thing.
There's been a lot of press recently about the budget for these Boeing, the Boeing and the Starliner and the SLS and all of that stuff, and
Right.
it's like pretty expensive.
Yeah.
So this is not going to help.
Right.
Not going to help them.
Yeah.
It's not. It's
Not
not
help their
really
case.
good for anybody.
It's
I
maybe
think.
good for SpaceX.
Yeah.
We'll see.
Depends on whether you want
I just
the,
want
the,
humans
the big
to go to
picture,
space.
humans to space, or you
Yeah.
or you want SpaceX to win.
I want
don't
humans
know.
to
I don't know
space.
whether I don't
It's
know which
not
one.
really a SpaceX versus Boeing thing.
Yeah.
In
Like,
some,
right, there are many airlines. There can be
Right.
many flight
Right.
dates.
both of them have already won contracts to
Right,
take
right.
cargo and people to the space station.
Yeah.
Fair enough.
The mole is digging again.
Yay! The Mars mole.
Mars Insight mole, which we had
Renee.
a team member on the Mars Insight lander, and this is this famous thing supposed to dig about 15 feet down into the surface of Mars and measure the thermal heat flux and
Yeah.
shaking. Is it just thermal?
It's just thermal.
Just thermal measurements in the
It's a
interior
heat
of
probe.
Mars, and it's this weird thing. It sort of hammers itself in, and it's pushing against the sides of the hole that it is digging. Is the thing that it's using to push itself down into the surface, and it sort of backed itself out. It ran into something, or the regolith was
gas pocket
looser
or-
than,
yeah.
so it didn't have anything to push against. So then they took a cover off, and then they planted some robot hand kind of next to it to give it something to push on. Then it started going down again, but then it popped back up again, and now it's going back down in again.
That's right.
So it's still
A lot
like
of out and in and
It's
out
a-
and in, and you gotta
yes.
sort of hold it there. And
right, and
you
guess
need
what?
friction, turns out, to
It-
make it work.
Right, and then perhaps not coincidentally, the Earth moved, or rather, Mars moved.
Mm-hmm.
Mm.
So all of that pushing in and pulling out, and then Mars had a Marsquake.
It did.
Huh.
Did it?
It did.
Oh, really?
Yeah, there was
I
an
didn't see
unusual,
that.
surprising Marsquake.
Oh, that's fun.
But that was before all this pushing in and pulling out.
Yeah.
So I think we've pushed that far enough. An exoplanet mission was launched by the European Space Agency. I'm afraid to try to pronounce it because it's an acronym that is spelled the same way as we frequently spell the Egyptian.
Cheops?
Yeah, that.
That's how I pronounce it.
Okay.
I don't know if that's
What
actually
is
how
it,
it's
Jim?
pronounced. I'm not. Well, I don't know. This is characterizing exoplanets satellite, or
Well, there you go.
characterizing exoplanet satellite. Does that make sense?
It does.
Cheops, characterizing exo.
Exoplanet.
Okay.
Yes, it does.
The E and the O come from exoplanet. E, O, and P come from exoplanet.
So most of
It should be
That's-
checksops.
Yeah,
Checksops.
checksops. Yeah, they just took that X out. Yeah, that's the kind.
I
I don't
hate
like
those
it.
kinds of acronyms.
Oh, you can't
Yeah.
just pick some random
Subset
assortment
of
of
letters.
letters
from the middle of the
word.
words. Right.
But they've done it, so I say you
It is
can't,
what
but they did
is.
it.
And so most of what we've learned about exoplanets so far has been there is an exoplanet there.
Yes.
And
Or-
occasionally it's this big.
Yes. Yeah.
And that's kind of it.
a
So
little bit of atmosphere
the,
stuff.
the next step is getting more about like
Mhm.
actually measuring atmospheres of these things, thousands of planets.
Right.
And this mission is going to look at stars that we know have exoplanets around them to try to. So a lot of the ones we're doing right now are
Just
still
discover.
looking for planets, but this one's going to try to focus more on stars we know have planets orbiting them that are pretty bright nearby stars to try to actually get some.
And not just
orbital
orbiting,
and-
but transiting, right? I mean, it's
Yeah.
you can find plenty of exoplanets that orbit that cause the star to wobble, but they don't. The planet doesn't cross in front of the star. But these, the transit method of finding exoplanets is what Kepler used, and
Yep.
what all these other things used, and what that in that case you can get that funny situation where some of the light from the star passes through the atmosphere of the planet, and then you can
Learn.
differentiate that spectrum from the regular spectrum of the star. And anyway, you can figure out something about the atmosphere of the planet.
This
So-
is my best hope for discovering really convincing evidence for life elsewhere in
Yeah.
the universe is seeing some really whopping biogenic signature like oxygen in some other planet's atmosphere.
Right.
Yeah.
So that's where I'm placing my money.
All right.
Like, exoplanet atmospheric oxygen for 20.
What do you think the over-under is in Vegas on exoplanet atmosphere?
I wonder. I bet. I'm sure there's some
There's
place where
probably
you can
somewhere.
bet some
If
place
you,
some bet
if you
on.
could conceive of betting on it.
Yes.
It's like Rule 42
There-
of the internet. Or
What?
49 or whatever of the internet. If you think of it, it exists on
Oh.
the internet.
Yeah.
But
Yeah.
also for betting.
Speaking of mission news, OSIRIS-REx has selected its sample site.
Yay!
So OSIRIS-REx is the NASA mission that's orbiting the asteroid, I don't know why I said it that way, Bennu. And this has been a real conundrum for them because when they got to Bennu and they had been planning to, drop down to the surface, and their sampling thing is they puff a little puff of gas to knock some dust and pebbles up into a little
Vacuum. It reminds me of like a shop vac because it has the filter kind of.
Oh,
where you
yeah.
put the filter in the middle, so it like puffs air in, and then the material sort of swirls up around the filter and gets collected. It reminds
Yeah.
me of a shop vac.
So that's the plan. Then they get to the asteroid and it's like made of boulders.
Yeah, they were predicting like centimeter size and smaller, but
Right, it's all meter size and larger.
meter size and larger.
And it's tough because they have to get really close to the surface, and it's your typical sort of boxy, gangly spacecraft with solar panels
Right.
dangling off the side, and those things don't like to come into contact with boulders.
It turns out.
And
Yeah, its sampling arm isn't that long. Like it's got
Right.
it's the tag SAM thing sticks out, but it's not that long.
like
It's
1 or
on the
2
order of
meters.
A couple meters.
Yeah, so that means that you've got to find a surface that's smooth enough so that the spacecraft body is actually going to be within a couple meters of the surface.
Yep.
And if the rocks are a couple meters high, you got yourself a little problem.
Yeah, so they identified 4 sites that they had previously narrowed it down to, and they named them all after different birds because that's sort of the theme of this mission. And they then announced during AGU last week, the big science meeting we were at, the sample site that they selected as their primary sample site is Nightingale, and their backup site is Osprey.
Ooh, nice.
And they're both, so all the 4 sites they'd selected are they look like craters, right? So they're sort of little indented regions, which you might not think would be the best, but it turns out that these regions all seem to be a little bit smoother than a lot of the surrounding regions. But all of them also have
They're
like a giant boulder on the
right
side.
next to it.
And you're like, maybe don't hit that.
And part of it is the ability of them to navigate the spacecraft position accurately was they were saying, we want a nice smooth region that's something like 40 meters on a side.
Yeah.
And it turns out the best they can do is like 10 or 20
25 or
meters on a side.
Oh, jeez.
So, but
Yeah,
I'm confident they'll succeed, actually.
I think so too.
Yeah.
JAXA set some pretty good precedent for like how well they were able to navigate down to the surface. So I
Right.
think,
With their Hayabusa 2,
Yeah.
Which has done multiple samplings of a similar sort of asteroid, and it's already completed several of those successfully. So that's exciting.
got a parallel park right into that crater.
Right. And I saw a Geminid fireball.
Congratulations.
We had the Geminid
lucky.
meteor shower a week ago. And our last, since this is our holiday podcast edition, the holiday astronomer news was that astronomers do all their work over the holidays.
That's true. There was a study that came out recently about how scientists in general, I think the study was actually like for
Yes.
a medical
Yes,
journal or
yes.
something, but scientists in general tend to submit papers and like paper reviews and stuff like that on weekends and especially over holiday breaks.
Right, because that's the only
That's like
time
when you have time to just sit and do that thing.
See, it's a very unfortunate thing because
Yeah, it's
it's
not a great
frustrating.
situation.
Because
But it turns out
science
we
is
work
not
then.
a tremendously well paid profession in general, and to be pushing all these scientists to be working over holidays and weekends and all that kind of stuff, they're not being paid that well to begin with. This is an unfortunate way to get science done in society. It'd be cool if you could get science done in a 40-hour week or a 30-hour week.
That would be amazing.
And that would be cool.
I don't know. There's enough people now. In theory, we could. We just have to change the mentality.
That's
of
right.
everything,
That's right.
Right.
That's right. I mean, the whole point of technology is people have to work less hard and.
Well, but also
Well-
just like the amount of scientists we have now, right?
Yeah.
Right. There's a
We
competitive
figure out better
aspect
ways.
to our research lives.
Yeah.
And when there's a competitive aspect, that means if you work on the holidays and the weekends, maybe you have a competitive edge.
Yeah.
Yeah.
So that's unfortunate.
It is.
Yeah.
Yeah, and so paper reviews, by the way, are like when we submit a paper that we think is, oh, here's my new science, 1 to 3-ish people usually review it. That's why it's called peer review, because it's reviewed by your peers, but that's like not something we get paid for.
That system is also broken
Also,
entirely because
it's also super bad.
publishers
right now.
of those papers make money. They make a profit off of that, and they ask the scientists to review them for free.
Yeah.
That's ludicrous.
It's crazy.
Let's fix the system, guys.
Fix the system. Yeah. Leading up to, also in the same holiday theme, and before we...
But not as upsetting.
Before I drop the trivia on you and we get to our main science topics for the day about hot spots and stuff. Well, our first science topic is about our old friend, I2 Borisov.
Old friend.
Well, since he's been in the, she or she has been in the solar system for a few months. And it has now made its closest approach to the sun on December 8th of this year, and will make its closest approach to the Earth. It is now on its way back out to continue its Walkabout the Galaxy.
Excellent.
On December 28th. So it's zipped around the sun. And so we've been continuing our observations of this object. Its closest approach to Earth is a fairly distant 180 million miles. What's that in real units? That's about 2 AU.
Oh, okay.
Right.
So not super close, but
not super
we'll get some
close.
Good imaging of it, probably.
Yes. So that object is being subject to a lot of astronomical scrutiny, including by Hubble Space Telescope has been observing it. So far, I2 Borisov is behaving like you would expect a comet to behave. It gets closer to the sun. It's sublimating, and lots of gases are coming off, and those gases look like the same ones that we see coming off comets from our own solar system.
Pretty interesting, huh?
Of course, we don't know which star it came from. That would be awesome if we knew which star, what kind of star it was, that sort of thing. There's not really a way to do that, because even if you could trace it, we could trace its orbit back and say, okay,
probably
it was near this other star, but that might have been another star like our own that it was making a random encounter with.
Has anybody done the calculation to see what star it's going to go to next?
I think so. Yeah, there was a paper we talked about during one of the journal clubs that was like figuring out where it came from and the perturbations in its orbit that would have gotten it to where it is now. And I think at the end of it they said where it might be going, but I don't remember what the answer is.
I mean, it won't be anytime soon. It's going to be obviously shooting off from our solar system in some randomish direction, and so it's obviously unlikely to
we're
hit
talking
another star anytime
probably
soon.
Tens of thousands of years at least.
We need to
probably more.
we need to do a rideshare opportunity with the next one we find, where like we send a spacecraft to intersect with one of these comets, and then it gets a ride out into the inner.
Oh, you mean it have to have it like gravitationally captured by that comet?
Yeah.
That's tough.
I know. We can do it.
We can do it.
Not right now, but
our trivia will launch us into our other two science topics about hotspots. A solar system hotspot and an astrophysical hotspot.
Okay.
The trivia is somewhat related to the astrophysical hotspot, so we'll do that one after the trivia.
Okay.
I'm ready.
Is it a multi-part trivia?
It is kind of a multi-part trivia.
Okay. What's the matter?
Did
you give away the answer?
Kind of.
Sweet. Let's do it. It's a good holiday trivia.
It is thought that one of the following events, and I say it is thought because it's not explicitly stated. Okay. It's an oblique reference, is referred to by Bernardo in Act 1, Scene 1 of Hamlet, Shakespeare's infamous tragedy.
Okay.
Your choices are Tycho's supernova of 1572, the apparition of Halley's comet in 1531, the disfiguring of Tycho's nose in 1566, the discovery of the Galilean satellites in 1610, or the discovery of Saturn's rings, also in 1610. Okay. One of those things is like referred to in Hamlet by William Shakespeare.
Okay. Good play.
Is it in the what's the movie actor? Kenneth Branagh of Hamlet?
I don't know.
He's the best.
I don't know. Okay. Let's talk about mapping the surface of a pulsar.
Yeah,
Cool.
that's
Oh,
gotta
yeah.
be a
Seems
challenge.
difficult. Seems difficult.
First, we have to remind ourselves what pulsars are.
Sure. So pulsars are the dead husks of large stars.
You love to use
It's
that
a
term.
Do
Dead
I?
husk.
Yeah.
Ah, it's a cool term. Husk.
I'm gonna do a compilation of Jim saying
I
dead.
always
husk.
think of a husk as being empty,
Yeah.
like hollow,
Yeah.
Oh, I guess.
like a husk of a
That's,
man.
they use it.
like-
I don't know. I've heard that term a lot. It's
Really?
It's the dead ember.
Ember is what I
Ember,
Okay,
use.
all
ember
right,
is
I'm
better.
in.
Okay.
It's the ember of a very large star that has died. So it's basically it's a neutron star.
We have multiple different kinds of stellar embers.
Right.
We've
So
talked about.
a sun-like star will end up as a white dwarf. A larger star will end up as a neutron star. A very large star will end up as a black dwarf. So, or not a black dwarf, black hole.
Next
So
year.
neutron star, if conditions are right, is in our sky termed a pulsar. Conditions are right meaning neutron stars tend to beam radiation away from their magnetic poles. And if you are in the path of that beam of radiation, then every time the neutron star spins around, you see a blip of light.
Like a lighthouse.
Like a lighthouse. And so we call that a pulsar. So all pulsars are neutron stars, but not all neutron stars are, from our perspective,
Ooh, a Venn
pulsars.
diagram.
Yeah, I had that, yeah. So anyway, there's a particular pulsar, PSR J0030 plus 05,
Ooh.
0451.
Ooh, such a great
Sexy name, I know. That is that we've recently been studying with a new instrument. The instrument is called NICER.
Aw.
Yet another one of these crazy acronyms.
That's also good for the holidays.
Which also it's not that great because it stands for Neutron Star Interior Composition Explorer.
Okay.
So the R at the end is from the middle or end of Explorer, I suppose.
Probably the end.
Where's the C from?
Composition. Neutron
okay.
Star Interior. So the star
The
doesn't
star
get anything. The
is
star
okay.
gets is a Neutron Star Interior Composition Explorer, which is on the International Space Station. Has to
Ooh.
be not. It doesn't have to be an International Space Station, but it has to be in space, right? Because
Yeah.
it is an X-ray observatory,
And our atmosphere kindly absorbs.
our atmosphere, yes, very. I guess
We appreciate that.
good for us.
Yeah.
It absorbs X-rays. That seems weird, by the way, because X-rays are higher frequency. They're higher energy light
Yeah.
than visible light,
Mhm,
and you might
mhm.
think of that as more penetrative than visible light.
Mm-hmm.
But we just so happen to have particular kinds of molecules in our atmosphere that like to absorb X-rays. And so,
Well, it's easier to absorb high energy photons than low energy photons, really.
it depends on
Depends on your
the frequency. But
If
yes.
it's by a gas, right? Because if there's molecules, any high energy photon can just dissociate it.
Right.
But if it's low energy, it's got to have the right energy to be able to be electronically absorbed or
Right.
absorbed by a
Absorbed.
That is
vibrational or
true.
rotational state.
That is true.
Okay. Okay,
Uh,
sold.
I'll buy it. Yep, absolutely. So anyway, luckily, X-rays are absorbed, but that hurts for X-ray astronomy because that means we can't make X-ray telescopes on the ground. This is also applies to gamma rays, even higher frequency light. But anyway, we've been using this X-ray telescope on ISS to look at pulsars.
It's also true that there's like fewer X-rays flying around out there.
Oh
than
yeah,
there
yeah. I mean,
are
even if
visible
you
light.
had, that's the thing. If you had X-ray vision, it'd be very stupid.
It'd be
right?
really dark.
It'd be idiotic because everything would be dark. I mean, even if you were in space, it wouldn't be that exciting because there's only a handful of really
I mean,
bright
somehow-
X-ray
but
sources.
X-ray vision like somehow involves you shooting
So-
X-rays out of your eyes.
That's right.
Is it?
Yeah.
Yes.
But then doing
like
and doing what with those?
then you
they
like can
bounce. They
see
magically
through-
bounce off things.
Yeah,
Somehow.
it's like if you get an X-ray image, right? Is how it works.
Yeah. So Superman's X-ray vision.
Is like he can
He can
see
see
things.
through things.
Right.
And it's like an X-ray image then.
Is it?
Yeah.
Well,
He's
but
seeing
it,
bones and stuff like that.
Yeah.
He's just like seeing people.
Yeah.
He's
He
like
just-
seeing through a wall
That's
and
his
seeing
point.
a regular
you see it through
version
the wall
of.
and see a person's there.
But he's not
but
seeing.
the
but when
X-rays
you-
would go through the people too.
Yeah, you would just see bones or something
Bones.
if you had a photographic
totally
plate behind
make-
them, and it's ludicrous. They just thought of a fancy, fun word, X-ray, and they added it to vision.
It's a metaphorical X-ray vision.
That's
Yes.
right.
So somehow it's working some other way.
But we
Yeah.
have
with
now
actual
X-ray
X-rays.
vision in space,
Yay.
and can use that to explore pulsars.
X-Lore?
So this particular pulsar, by the way,
But
some of these pulsars.
What would Superman's eyes need to be made of if it was really X-rays? It'd have to be like this nicer instrument, right?
Mm-hmm.
So his eyes would have to have whatever materials it is that can absorb those X-rays or detect them somehow,
But
instead of the X-rays just
X-rays
go.
don't really. They don't reflect off of these surfaces. X-rays are either like
Well, they
penetrate
use
or absorb.
they use these scattering things at oblique angles on X-ray telescopes.
Yeah, yeah. Real
I'm just trying
X-ray
to figure
vision.
out what Superman's eyes are made of.
Yeah,
here.
yeah.
Work
Well-
with me here.
Okay.
Mirrors, but
What are
mirrors
X-ray
placed at weird
detectors?
angles. So, anyway, let's get back to the
They
pulsar.
have
The pulsar
concentrator
here.
optics and a silicon drift detector in NICER.
Okay.
So it's a silicon detector that will measure things within the 0.2 to 12 keV X-ray band. So you just need detectors that are sensitive to those higher energy
I don't know what that means.
Well,
All right.
bands.
Jim's more interested in pulsars. I'm more interested in Superman. But go ahead.
Now I'm interested in the detectors.
The pulsar,
so
yeah.
well-rounded.
we're all interested
All
in
right,
different
go
things.
ahead. Tell us
the
about
pulsar,
the pulsars.
This particular pulsar, so pulsars tend to spin very fast, just like figure
True.
skaters when they bring their arms in. So when a star, when its core collapses at the end of its life, it starts to spin faster and faster and faster because of conservation of angular momentum. These guys are spinning very fast. This particular one spins once every 4.87 milliseconds.
That's too fast.
That's
insane.
250 times a second.
250
or something?
times a second,
Or
it's spinning. Is that right?
200 times.
200 times a second. That's insane. That's something the mass of roughly the sun spinning 200 times every second is an insane thing to think about.
And it not like flying apart.
It doesn't fly apart because its gravity is
crazy.
insanely
It's
strong.
insaner.
One of the results of that are very powerful magnetic fields. And this, of course, is why it's a pulsar, because the powerful magnetic fields cause these beams of radiation to fly out. But what
Magnetic fields are weird.
Magnetic
Can we
fields-
just say that?
Yeah.
They are very, very weird. And it turns out on these pulsars, they're weirder than we expected. These, by the way, these magnetic fields around pulsars are crazy. They're like 10 trillion times or something stronger than Earth's magnetic field. They're
And part of that, so correct me if I'm wrong here, but you take the star's which is usually the case. The star has got some magnetic field, and when it is compressed, it's a little bit like the same ice skater analogy. The magnetism, or at least most of it, does not disappear. And so now you have a much smaller object with the same total amount of intrinsic magnetism, and you can be much closer to that. In other words, the star has gotten smaller by like 100 times. So it's like if you took the sun's magnetic field and scrunched it in. What I'm trying to say is magnetic fields are stronger when you're closer to the magnet than when
True.
you're farther away.
yes,
True.
absolutely.
Part of this is because the star is very small. You
Yes.
can get closer
It's like
to it.
Yeah, it's like the same magnet, but
Like-
you're much closer to it. Something
That's
like
what
that.
I'm trying to say.
Right. I mean, the magnetic field we don't understand the magnetic field of these pulsars very well. And that's part of what this mission was trying to understand, is to map out, because as the magnetic field penetrates the surface of the star, that changes the temperature of the surface of the star. And so they were trying to map out, are there big temperature differences over the surface of the star? Now that's really hard, because this neutron
It's
star that we're
tiny.
talking about is tiny. So we can't actually resolve the surface of this neutron star, because
Yeah, the whole thing blows my mind. That the title of this, is like mapping the surface of it.
right. So you're not mapping it by like taking a picture and seeing it's hotter here than it is here, but you can map it out by, you watch as it rotates, because it's rotating very, very quickly. You can see it gets hotter, colder, and by the pattern in which it gets hotter and colder,
Yeah.
you can kind of map out roughly what the temperature blobs look like on the surface of this thing. It turns out you can't really uniquely do it, so what we do is they make computer simulations which say, okay, let's say we had a hot blob here and a hot blob here, and spun it this quickly.
Here a blob, there a blob.
Would that look like the data that we get?
Typical
No.
simulation.
All right, let's put a blob there and a blob there. Would that look like the data that we get? Yes, right? And there's a few different patterns of blobs that give you the right answer, but they're all similar-ish, and they show you that there are a few hot spots on the surface of this neutron star that aren't actually in the places we predicted they would be.
Right. And
You
so
love a
it could
good
have.
simulation where it says, these patterns of blobs are similar-ish.
Yeah.
That's the way I write all my simulations.
Yeah, that's right. And if you want funding for this, that's how you write to your funding agencies. We're going to look for blobs, and we're going to use these supercomputers to do it.
See if they're
So
similar-ish.
what would have been expected would have been a hot blob at the North Pole and the South Pole.
Something
and that's
like
it.
that. Right. And
Basically,
we don't
and a sort
actually
of
see that.
smooth gradation in between.
Right.
And it's lumpy.
Right. That's what you'd expect. Like if the magnetic field were like that of a bar magnet, then you'd have these really powerful magnetic fields right at the north and south magnetic poles. And there is a north and south magnetic pole. That's where this radiation is beaming from. But it turns out the magnetic field on these things is actually drastically more complicated than we thought. That's what
Right.
that's the
That's
kind
the
of
punchline.
take-home message
Which
from
is
this.
probably not that surprising, because we don't even understand our sun's magnetic field very
not
well.
not terribly
Right.
surprising,
And
but
it's lumpy.
interesting.
And it's lumpy and weird and changes throughout the year and throughout the
Right.
cycle.
I mean, all
and
these
that stuff.
these fantastic images that you see of solar flares and things like that are
magnetic
these
field lines.
magnetic hot spots that are not like a single giant bar magnet. The Earth, Jupiter, Saturn, they have sort of bar magnet-like
But even
magnetic
the Earth's
fields.
bar magnet is super complicated.
Right. We don't. Yeah. Turns out magnetic fields are really complicated for all astrophysical things.
Yeah.
They're just weird.
They are weird.
Magnetic fields are weird. You
They're
can't
weird.
have just a north pole by itself. Like you can have
There's
a
no
positive
monopoles.
electric charge, but you can't just have a north magnetic pole.
Yeah. Okay. Random question for you guys before we leave this topic and talk about
Yes.
hotspots
Talking
on
about-
planetary things.
Yes.
Okay.
I was reading the paper in which they were discussing this business,
Ta-da!
and one of the fun facts that they mentioned for this thing is that they've measured also the time derivative of the period. That just means the rate at which the period changes.
So
Okay.
is it spinning faster or is it getting slower or faster? I hope it's getting slower.
It's going to be getting slower, right? Generally, these things are always getting slower.
Otherwise-
As they lose energy, they slow down. But the rate at which it's slowing down, they measured, not this thing, but it has been measured before as 1 times 10 to the minus 20 seconds per second. So that means it's slowing by, every second, it slows by 10
So
to the minus 20
A
seconds.
decimal point with 20 zeros.
My question to you guys, so I don't know the answer to this,
Accurate.
is what?
Okay.
How in the heck
Do they
are they
measure
measuring
that?
that? Because that means in 10 to the 20 seconds, it would slow down by 1
1 second.
second.
That's
Right.
a long
But 10
time.
to the 20 seconds
Is
is
much, much longer than the age of the
1,000
universe.
times the age of the universe.
Yes.
Yeah.
So how in the heck are they measuring? If you wait,
So let's put it. So
I
if
mean,
we
it's a derived value, so it's...
if
derived
we,
from what?
well, let's say you measure it for a year, then you're measuring a change in the period of 10 to the minus 13 seconds, roughly.
Can they
right?
measure that?
Well, I don't know, but let's at least just get it there. Okay,
Yeah.
so, but we don't know, Jim.
I know. I
Yeah.
don't think anybody at
Why
this
are you-
table knows, but maybe somebody out there in our listenership knows how they made this measurement.
Listener challenge.
Listener challenge.
How
do
is
they
the
figure out?
deceleration rate of a pulsar measured?
Right. I mean, some of them slow down at rates that you can,
the-
over the decades, watch them slow down.
The
But this
easiest
seems
way,
like-
the easiest way would be you measure how fast it's rotating now. You measure how fast it's rotating a little bit later.
Right.
And then you see,
Right. You see how it's
much
changing.
sort of-
Right.
But
Is
what
that
you're
they did
saying
for
is that this rate
seems
is
like that rate is too slow to do that. But maybe I'm wrong. Maybe I'm just an idiot. Maybe they can measure this period more precisely than I think they can.
I'm just trying to usually for
I'll
things
look
that are
over. I'll look at this
super-
over the holiday break as well.
Okay, great.
Yeah, sometimes it has to do with like sort of I'm trying to think if there's any sort of Doppler shifty type thing that could be
Probably.
going on with it.
I don't know.
Probably.
We'll think
There
about it. You
usually
guys think
is.
about it as well. All right. What about
Okay.
this planet thing?
I just wanted to mention it's related to the planet thing. What you were saying about the statistical models about where these hotspots are. So with the pulsar, they're like identifying how many hotspots do we need to reproduce the pattern of brightness that we see the thing is rotating. We do the same thing with planetary objects to like get the shape of distant objects that are too small for us to see by just looking at reflected light. And we see, oh, it's bright, it's dark, it's bright, it's dark. And also with the object that now has an official name that New Horizons flew by, the Kuiper Belt object
Arakoth.
which is this snowman type
Yes. Maybe
object.
smooshed snowman or something.
Cookie gingerbread person object, two lobes kind of stuck together. That was predicted correctly ahead of time
Based on these light curves.
based on the same sort of Bayesian statistical analysis of, well, there's not a unique solution, but we can guess a million different solutions and 98% of them come up with two blobs stuck
Right.
together
Yeah.
to fit it. And the other, to have something else, it would be weird.
Yeah. So
Sort of
supercomputers
random
have
chance.
uses other than porn or whatever. So that's awesome.
Yeah.
Great.
The other
It's
the
great.
other hotspot thing actually ties in nicely to this. Has to do with one of my favorite moons, Saturn's moon,
The moon?
Enceladus.
Oh.
Not your favorite
Oh,
moon.
Enceladus. That's a good one.
It's fine.
It's this tiny tiny little moon. It's about the size of Great Britain, orbiting Saturn, and it's curious
Pre or post-Brexit?
curious and charming because it has geysers. It has water vapor spewing out of the South Pole. And so, analogously to the hot spots on this pulsar, Cassini measured the temperature on this moon and what we expected, where do you expect it to be hot, where the sun is shining. And it turned out that it was a little bit warm there, but it was really toasty warm at the South Pole,
Yeah.
which is not where the sun is shining on this particular moon. Then we did all these close-up
Tiger
images
stripes.
of everything, and it turned out to be that there were these 4 big fissures across the South Pole, which were nicknamed tiger stripes, and they were given names like Baghdad, Cairo, Damascus,
Oh, that's kind of fun, 'cause they're hot.
Alexandria, Baghdad, Cairo, and Damascus,
Yep.
and then there's an E, which they haven't given a name yet. But it turns out, I just learned that the naming scheme for those stripes is places that appear in 1001 Nights
Oh,
for some
I just
reason.
thought they were hot cities. Because
Oh.
the fissures are hot.
Well, that works as well.
Yeah.
So, and water vapor spewing out of these fissures in the South Pole, and so there's been new research that says, why do we have these stripes and why are they at the South Pole? Well, South Pole, North Pole turns out to be a flip of the coin, just to sort of jump to there, but why is it at one pole or another? And that has to do with you get a thinning of the ice at one location that will preferentially tend to rotate around,
Yeah.
rotate your around to the pole.
Because your mass is distributed in like the way you're like it's when you have like if you have a little mass with a wobbly thing on the inside, right? It'll want to rotate a certain way. So
Right. And so the water, when you start off with some subterranean liquid ocean on Enceladus, and it starts freezing a little bit. It freezes faster at the poles also. As soon as it's thin enough, then some of that water starts spewing out of a crack. So the suggestion is that the first fissure to form was the one that's been named Baghdad, and it's spewing, for lack of a better word. I'm open to suggestions. It's
a pretty good word.
It's geysering snow, basically, out of this crack, which then falls down on the surrounding terrain, and that piles up at the margins and creates new cracks. So you make one crack, and then you spew out neighboring cracks, which
It's
puts
just
a
the weight
strain.
of that stuff cracks the ice.
And then you get the new cracks, Cairo and Damascus, on either side of Baghdad. Then they're spewing stuff out, which leads to
interesting.
additional weight, which led to Alexandria and the E crack.
Interesting.
So you have this sort of cascading sequence of things that took on the order of 1 million years. Our 13 years of measurements from Cassini showed basic constant production of water from these things. It's conceivable that it could have been going for the age of the solar system.
Really? It wouldn't have lost too much. How much material gets lost if it's going for the age of the solar
That would have been
system?
an excellent trivia question,
It
but I'll
would
just
have.
tell you the answer. It's
Okay.
10%. So
10% of the mass of the moon? That's it?
yeah.
Oh,
If
wow.
if it erupted at its current rate for 4.5 billion years, it would lose 10% of its mass.
So that's plausible.
So
then.
it's plausible that that could happen. And we don't really know exactly how the interior of this very tiny, very distant moon is being heated. There's the usual mechanism for this sort of thing, like with Jupiter's moon Io, is that there's tidal stretching of it, then the friction warms
When
stuff
you
up.
pull a rubber band, it warms it.
But usually with Io, we see this very clear forcing that's causing Io to stretch. We don't see as clear a mechanism that's causing Enceladus to stretch.
Yeah.
And it's one of these weird things. It's like if you start off warm and molten, then it doesn't take your response to the other moons is different than if you're solid. And so if it starts off molten, it's easier to kind of keep it molten than it is to like halfway through the age of the solar system start shaking it and then make it melt.
Yeah.
Right.
So it's this weird thing that sort of suggests maybe it's been molten all that time. But this particular study suggests that it only takes about 1 million years to form these particular features.
It's not very long.
That doesn't mean that they're only that old.
Right.
Yeah.
That's
I mean,
an interesting
interesting.
hint. If it's if it's possibly been molten the whole time, because you want life. What you need is liquid water for a
Oh,
long
and we
time.
want life.
Yeah,
We do want life.
I know.
Yes.
There's if you watched going back to like nerd news, have you been watching Watchmen at all? Also an HBO
I
show.
have not.
There's a whole thing with Europa on Watchmen
Oh, cool. All right.
Mm.
A
and
Europa-
life on Europa.
We'll have to tune back in later for a Europa report from the
Uh-huh.
Watchmen. Okay, let's go back to Hamlet.
Let's.
Which astronomical event is referred to obliquely by Bernardo,
Is that a
Act 1, Scene 1 of Hamlet?
Okay.
Tycho's supernova of 1572,
Mm-hmm.
the apparition of Halley's comet in 1531. The disfiguring of Tycho's nose in 1566. The discovery of the Galilean satellites in 1610 around Jupiter, or the discovery of Saturn's rings by Galileo, also in 1610. What sayest thou?
Comet.
Well, you gave away the answer.
I did stupidly give away the answer, which is
The first one. Is Tycho's supernova.
Tycho's supernova, which is why it makes. I was like, oh, this is a great segue to the thing. And it's like, oh, it's only a great segue if you know what the answer is.
Yeah.
Damn it! It is Tycho's supernova.
Good job, Jim.
I think I would have guessed that anyway, just because it's the baddest ass of those. Pardon my language. Those bleep that.
Here is
of those
the
things. Supernovas. Awesome.
Here is and we had not too long ago talked about supernova 1987A, which is the most recently observed supernova in our sort of galactic home. It's in the Large Magellanic Cloud, which is the suburbs of the Milky Way, sort of. But there's still this weird thing where when we look at other galaxies like our own, the rate seems to be about a supernova every 30 years or so.
Popping off all the time.
And they're not popping off in the Milky Way for some reason. So in the last 1,000 years, there have only been 3 naked eye supernova supernova in our galaxy. And that's including the one in the Large Magellanic Cloud. And the supernova of 1572 was observed by Tycho. And then there was one in 1604.
Right.
So that was 30 years, and then it's like what the heck's going on here? 400 years?
Yeah, and it sucks because that's when we developed telescopes. In the last
it's
300 years.
Really a raw deal.
Yeah.
But Tycho's observation of this supernova helped with the construction of the Aristotelian view of the unchanging heavens. Here is the verse from Hamlet. Last night of all, when yond same star that's westward from the pole had made his course to loom that part of heaven where now it burns, Marcellus and myself the bell then beating one. At least I think that's the verse.
Huh.
Okay.
It sort of sounds to me like it's the Tycho's comet more than Tycho's, because he also observed a comet at around that same time frame, and that comet was another piece of this whole puzzle that showed that the heavens were not constant. Right. This sounds a little bit more like Tycho's comet than Tycho's supernova.
Trivia invalidated.
Yeah.
It's too bad.
Here's your bonus adjacent trivia.
Okay.
Which of these authors also mentions this supernova?
Okay.
Heinlein, Robert Heinlein, F. Scott Fitzgerald, Ernest Hemingway, Albert Camus, Edgar Allan Poe.
I'll go with Edgar Allan Poe because we talked about him last time or a couple times ago.
I was going to say that too. So Hemingway.
It is Poe. Yeah.
You took it.
Okay.
Sorry.
It's okay. Well, yeah, we did talk about his astronomical observations last time.
Yeah, smart guy.
We talked about Poe figuring out Olber's paradox, right?
Yeah.
Yes, why the sky is not bright.
Right.
Yeah. Well, it may have felt like the time for the Mars Insight mole to dig a hole.
Good one.
It was just another episode of Walkabout the Galaxy. If you like this episode of Walkabout the Galaxy, write us a review in the classic scientific programming language Fortran on punch cards and scatter them at a ticker tape parade. Or iTunes. Be sure to like us on Facebook to get all our updates and check out our website at walkaboutthegalaxy.com. Subscribe to our YouTube channel, Walkabout the Galaxy. Are you sensing a pattern here? Where you can see our snazzy Walkabout t-shirts.
Great holiday gifts.
Available from walkaboutthegalaxy.com. Catch up on old episodes wherever you get your podcasts. Thanks to our listeners in Norway and around the world. Follow us on Twitter.
At walk_the_galaxy.
And ask us questions anywhere using hashtag walkaboutthegalaxy. Our theme music was composed by Richard Drusik. Our production assistant and video guru is Diego Rodriguez. I'm Josh Caldwell.
I'm Addie Dove.
I'm Jim Cooney.
We're the Astroquark signing off until the next episode of Walkabout the Galaxy.
Blobs.